Students, welcome to the video number 7. Now in this video I am going to discuss optical activity. I think probably you would have studied this unit, optical activity, dextrorotatory, levorotatory, in chemistry also. Okay, let it be that. What is optical activity? First I will explain, next I will define it. Say, this is the plane of vibration of the light. This is the plane polarized light. This is the plane polarized light. This is the direction of propagation. This is called as a plane of vibration. This plane of vibration, it is in a direction perpendicular to the what? Propagation of the light and all that. When such kind of light, whenever it is passed through any solution, that is, this is the one solution is there. Some solution. I don't know what kind of solution it is. It may be sugar, cane juice, or any sugar solution, or any juice or something. Whenever such kind of light is allowed to pass through this light, what happens? It will, the plane of vibration, it will be rotates here. The plane of vibration is rotates. Or sometimes you might ask question, why it vibrates only in the what? Clockwise direction. It is like this. Sometimes the plane of vibration, it may be like this. It is, with respect to this, it is anti-clockwise. It is with respect to it is what? Clockwise direction. Now I will define it. Optical activity is a phenomenon. It is a process. It is a phenomenon. It is a property in which certain substances rotate the plane of vibration, the plane of vibration of polarized light with respect to direction of propagation of light. What is the meaning here? Whenever there is such kind of plane of vibration, plane polarized light, when it is allowed to pass through any certain solutions here, the plane of vibration will be what? Rotates here. The rotation may be clockwise or rotation may be what? Anti-clockwise. Such kind of phenomenon is called as an what? Optical activity. Optical activity is a phenomenon in which certain substances is having the property of what? Capacity or property to rotate the what? Plane of vibration of the plane polarized light. Here there are two types of optical active substances. This phenomenon is called as optical activity, and the substances which exhibit this property are called as optically active substance. And substances are called optically active substance. Optically active substances. The liquids or any materials which exhibiting this property are called as what? Optically active substances. And this phenomenon is called as what? Optical activity. Now, you see here one is clockwise rotation and other one is what? Anti-clockwise rotation. This is called as dextrorotatory. It is called as dextrorotatory. This is called as levorotatory. It is called as levorotatory. What is dextrorotatory? Where dextrorotatory is the one where there is plane of vibration rotates in what direction? Here it is in a clockwise direction. It is what? Clockwise rotation. It is called as clockwise rotation. Here it is anti-clockwise rotation. Here it is anti-clockwise rotation. Anti-clockwise rotation. Now, optical active substances are classified into what? Two types. One is dextrorotatory and another one is what? Levorotatory and all that. Here, dextrorotatory example is quartz. It comes under this. Any sugar solution comes under what? Dextrorotatory. But for the levorotatory, any juice, that is fruit juice comes under the what? Levorotatory. here under this heading dextrorotatory, the cords is a good example and sugar solution is a good example. Here it is what? The fruit juice and all that. Here, once again I will write. Optically active substances are classified into what? The substances. Optically active substances. Optically active substance is classified into what? Two types. One is dextrorotatory, and another one is levorotatory. Dextrorotatory or levorotatory, or else it is called as a clockwise rotation. It is also called as right-handed rotation. It is called as a right-handed rotation. Right-handed. This is called as left-handed rotation. Left-handed rotation. Or sometimes it's called clockwise, and this is called as what? Anti-clockwise and all that. Examples for this is cords and sugar solution. Example for this, fruit juice comes under this category. Fruit juice comes under this category. Okay. Next one is Biot's law of optical activity. Next one is Biot's law of optical activity. Okay. Here, this law, what it says is, I said that it rotates in the clockwise direction or else what? Anti-clockwise. Once again, will tell you, this is the what? Plane of vibration, that is plane of vibration. This is the propagation of light. When such kind of plane of vibration, plane polarized light, then it is allowed to pass through the solution. I said that this will be rotates in what direction? Clockwise direction. It is called as clockwise. It is called as right-handed rotation. It is called as right-handed. If it rotates in this direction, that is what? In this direction, anti-clockwise, it is called as left-handed rotation. Left-handed rotation. Rotation. But here, how much angle it is rotated? Theta. It depends upon what are the factors, how much it is rotated. Whether is it rotated by 10 degree, 12 degree, 15 degree or what. It is explained by what? That is Biot's law of optical activity. It depends upon what are the factors. Amount of rotation. Yeah. Amount of rotation of plane polarized light. Amount of rotation of plane polarized light in optically active substance. Depends on. This is formal question on what are the factors. It depends upon, that is, first one is theta is directly proportional to C. C nothing but concentration of the solution. Concentration of the solution. I think you did polarimeter experiment, you did sugar solution. You are gone diluting and all that. Second one is theta is directly proportional to thickness of the solution. That is what? Or length of the what? Solution, or thickness of the substance. Or some books will write L, they will write. That is what? Length of the solution, that is. And third one is theta is directly proportional to what? Temperature. Then another one is, fourth one is theta is directly proportional. Theta depends on type of the substance. Students, by using polarimeter experiment, you can find what is the percentage of sugar that is. You can find it. Whether the sugar is, how much it is purity, that you can check it. For all the sugars, don't think that theta is same, because again it depends upon that is what the purity of the sugar and all that. And also it depends upon the wavelength of the light also. Now I will write theta is directly proportional to T and C. Some books they will write L, they will write. This theta equal to proportionality constant S into what? T into C. This S is called as in what? Specific rotation. That's another physical parameter. Specific rotation. This S equal to theta divided by what? T into what? C. What is the unit of T here? Radian. SI unit is what? Radian. I will write. This is an unit is what? Radian. Thickness, it is in what? Meter. Concentration, how you are measuring? Kg per meter cube and all that. Here, kg per meter cube means what happens? This 1m and this 1m will be what? Get cancelled. What is left here? It is m to the power of 2 is left. Here, radian kg per meter square. Or else, I can write radian m to the power of what? 2 kg to the power of what? Minus 1. This is the unit of what? Yes. Yes is called as in what? Specific rotation. I think you're using polarimeter experiment that is in the laboratory, may have calculated the value of yes and all that. Okay. Here, next one is the assumptions of the Fresnel's theory of optical rotation. What are the assumptions are made by deriving this equation? Okay. Now, it is a 4-mark question. We explain what are the assumptions made by the what? Fresnels while explaining the optical rotation. First one, when a plane polarized light passes through optically active substance, it splits up into two circularly polarized vibrations, where one is what? Right-handed rotation, and another one is what? Left-handed rotation. This is first part, very simple. When a plane polarized light, it is allowed, enters into the what? Optically active substance. It splits up into what? Two circularly polarized vibration. It is two circularly polarized vibration. That is important. Two circularly polarized vibration. One is right-handed rotation and another one is called as what? Left-handed rotation. That is. Next point you say, in an optically inactive substance, like optically inactive substance, both the right-handed rotation and also what left-handed rotation is that now, where the speed of this VR equal to what? VL. The speed of this right-handed rotation and also the speed of the left-handed rotation, both are what? Same here. R subscript is what? Right-handed rotation and L is the what? That is subscript is what? Left-handed rotation. Both speeds are what? Same only. This is the situation when the light will be passes through what? Optically inactive substance. And You might ask question, what about this in case of active substance? In in an op, in an optically active substance, in optically active substance. Here, the speed of rotation, the vibrations of both are what? Not same. That is, VR and VL both are not at all same. One will be travels with the more speed and one will be travels with what? Lesser speed. Now you might have asked the question, which is in where the VR is greater and where that is VL is what? Great. It is greater. In a dextro-rotatory substance, important point. Next derivation is that. There I am using. In dextro-rotatory substance, here VR is greater than VL. In dextro-rotatory substance. In levo-rotatory substance, LAE, levo-rotatory substance, VL is greater than what? VR. See, here I given one example here. Here it is inactive substance. Once again I will explain it here. This is what kind of substance here? When a plane polarized, here inactive substance. In inactive substance, VR and VL both are what? Same here. So that distance traveled by right-handed rotation, this one, and distance traveled by left-handed rotation, both are what? Same. So that both are in phase. So that there is no phase difference is created here. And this is the what? Emergent light. Here, this is the incident light. This is the what? Emergent light. There is no phase difference here. No phase difference. This is the situation in which kind of substance here? Optically inactive substance. But look into this here. I given one example. In dextro-rotatory, VR is greater than VL. Now this is the solution. Then the light will be entered. It splits up into what? Right-handed rotation and also what? Left-hand rotation. Here the speed of VR is greater than the what? Speed of what? VL. Then definitely what happens? There is a phase difference is created between the what? Between the, that is incoming wave, and this is the what? Emergent wave. There is a phase difference is created. This phase difference I will call it as a what? Theta. In the calculation, theta equal to what? Pi by 2. This also theta from the geometry. This also what? Theta here. That means here the light is entering like this. The light is entering like this, but it emerges like this. I think you understood this. Light emerges like this. But here this is, one second, I'll tell you what that is. Light enters like this, but emergent light is like this. This is the what? The phase difference is what? Created. But in this case, no. The light enters like this and emergent light is also what? Like this. Here the phase difference equal to what? 0. But here the phase difference is created between the incident light and emergent light here. Why it is possible here? Because the speed of both right-handed rotation and left-handed rotation both are what? Different here. They may ask you the question in the objective type here also. Here we don't know this. What kind of question paper is there? Is it descriptive type or what? Any objective type here. But remember, in dextro-rotatory, VR is greater than what? VL. In levo-rotatory, VL is greater than what? VR. Remember this formula, just this point you remember, I'm going to use in the next mathematical derivation. Next question is, derive the equation for the Fresnels theory of optical rotation. Normally it is a 8 marks or 6 mark question. Derive the equation for the Fresnels theory of optical rotation. Okay, now I'll derive the equation for the Fresnels theory of optical rotation. Remember, this is what? Incident light. It splits up into what? Right-handed rotation and also what? Left-handed rotation and all that. I'm dealing, suppose I'm assuming that it is dextro-rotatory and all that. Remember, students, if the amplitude is what, 2A, that is incident, it splits up into 2 now. This amplitude is also A, this amplitude is also what, A. That is because of division of what, amplitude. Let us consider one wave y equal to 2A into sine of omega t. This is the incident wave. This is the equation number 1. Call it as. Of course, I am not using this. No need to give this equation 1 also. This is the incident wave. What is the amplitude of the incident wave here? 2A. It splits up into what? 2 parts. That is, one is amplitude is right hand rotation and A is the amplitude for the what? Left-handed rotation. It divides equally. Now, on entering this left-handed rotation is there. Now, I will left-handed rotation components I am taking. Left-handed rotation components. I am taking the components x and y components I can take. This is the x component and this is what y component. Yes or no? X component is negative sign now, so that I will write x1 equal to minus of what, A into what, sine of omega. Please students, concentrate on this. The frequency before and the frequency after entering the solution, it will not change. The frequency will remain same. Here also it is frequency is omega before entering, and after entering the solution also there is what, the frequency will remain same. Only the amplitude will what, changes. This is x component. And y component, it is a positive y direction. I am writing y1 equal to A into sine of omega t. I am writing. Next. Similarly, another component is that this component, right-handed rotation. Right-handed rotation components. Right-handed rotation components. This is divided into 2 components. One is along x and another one is along what, y. Of course, this is positive x, this also what, positive y. So that x2 equal to plus only A into sine of omega t plus of phi. I tell you why it is. Y2 equal to A into sine of omega t plus of phi. Now, very interesting thing. Why I included the extra phi is that no, here there is a phase difference is created between the left-handed rotation and also what, right-handed rotation. As I told you, there is an optically active substance. In optically active substance, the speed of this and this speed is what, different here. So that here this is the dextro-rotatory substance. It is a dextro-rotatory substance. In dextro-rotatory substance, VR is greater than what? VN, I told you that is. So that when the speed of this right-hand rotation is more, then certainly the phase difference is also what? More with respect to what? Left-handed rotation. I think it is clear for you that is. Here I have taken for what kind of solution here? Dextro-rotatory substance I have taken. Next, I am adding the components. Okay. Now adding the components, x equal to x1 plus x2 I am writing here. X equal to x1 plus x equal to I am writing equal to minus A into what? Sine of omega t plus A into sine of what? Omega. Which is the common factor here? A is the common factor. So that x equal to A into sine of omega, one minute, that is A plus of what? Phi. A is a common factor, sine of omega t plus of phi minus of sine of omega t. I think it's clear for you. Here it is A, here also A is common. First I am writing this term here, sine of omega t plus phi minus of what? Sine of omega t. You use the formula of sine A minus sine B, you use the formula. That is using that standard equation, x equal to 2a into cos of a plus b by 2, that is omega t plus of phi plus omega t divided by what? 2. Can I write like this? Because 2 into cos of a plus b by 2 into sine of a minus b by 2. A minus b means omega t plus or phi minus omega t divided by what? 2. This is the equation I am using that. Here, which are the factor get cancels? You see, that is x equal to 2a cos of, this is omega t, this is also what? Omega t. Omega t plus omega t equal to what? 2 omega t divided by 2, nothing but omega, plus of what? 5 by 2. And this omega t is get cancels into sine of what? 5 divided by 2. This is the value of what? X here. I think you understood this. Okay, similarly, I will add y component. I will add it. I am using this one. I will write somewhere. I will write here. What is x? X equal to 2a cos of omega t plus 5 by 2 into sine of 5 by what? 2. This is the one. Equation 1 I will call it as. Okay. Now I will add similarly y components. I will add it. Y components. Start out it. y2 equal to a into sine of omega t plus of what? 5. I will add it. These two terms I will add it. Y equal to resultant equal to y1 plus y2. Y equal, you write. What is this? A into sine of omega t plus of a into sine of omega t plus of what? 5. Then y equal to, a is a common factor. I will write sine of omega t plus of 5 plus of sine of omega t. Use the formula sin A plus sin B. You formula, use it. Y equal to 2a into cos of a plus b by 2. A plus b by 2. Omega t plus 5 plus omega t divided by what? 2. Okay. 5. Into cos of a minus b. This one. Omega t plus of 5 minus omega t divided by what? 2. This time. Now, this y equal to 2a into cos of omega t plus omega t equal to what? 2 omega t divided by 2, nothing but omega t plus 5 by 2. And into cos of what? This value cancels. It is what? 5 by 2. This is one is x and another one is what? Y. You got it. Now I will rub it. This portion I will rub it. Resultant x and resultant y you can write it. Resultant y equal to 2a. It is what? 2a into cos of omega t plus 5 by 2 into cos of what? 5 by 2. This is equation number 2. Now what I am doing is, I will divide both equations divided. X divided by y equal to, I will divide it. This factor, this factor, this factor, this factor. Here what you are getting is sine of 5 by 2 into cos of what? 5 by 2. It is nothing but tan of what? 5 by 2. It is just like a equation straight line. X equal to y equal to mx. It is like that. It is the equation of straight line. This represents the equation of a straight line. This represents equation of a straight line. With phase difference theta equal to what? 5 by 2. This the phase difference is what? Created. Now, I know the one standard formula, I know that. path difference and phase difference, we know that. Phase difference equal to, that is what? Phase difference phi equal to 2 pi by lambda into what? Path difference. It's a standard formula. You are using this one in interference and also in a diffraction chapter. This phi equal to 2 pi by lambda into bracket. Into bracket of what? NL minus NR into what? T. That is, it is an optical path. NL, NR into. What is NL? It is the refractive index of left-handed rotation, and this is the refractive index of what? Right-handed rotation. Here some confusion, doubt may occur. Why you are writing NL minus NR? Why not NR minus NL? But since I am taking with the dextrorotatory substance. In dextrorotatory, velocity of right-hand rotation is greater than the velocity of left-hand rotation. But I know the relation between N and V. N equal to C by V. If this is V is more, N is what? Less. If V is more, N is less. So that NR is less than certainly NL. Which is greater here? NL is greater. That's why I have taken NL minus NR into what? T I have written this. This is the equation. But here phi equal to this. What is the phase difference is created here? It is phase difference equal to pi by what? This theta equal to the phase difference theta equal to, I will write this theta, I will write theta equal to this one. This theta equal to pi by 2. This is pi by, I will equate it, equal to 2 pi by lambda into NL minus NR into what? T. Then which factor then cancels? This phi is what? It cancels here. Then substitute here. Then theta equal to, what is that? Theta equal to pi by 2. 1 minute. Theta made not pi, it is what? Pi by 2 it is. Okay. Now it is not cancels, I made mistake. Equal to, therefore phi equal to 2 I multiplied here. 4 pi by lambda into bracket NL minus of NR into what? T. This is the equation, that is. Or else you can keep in terms of velocity also. I can represent here in terms of velocity. The same equation is what? The same equation is phi equal to, I made mistake, theta equal to pi by 2, that is equal to 4 pi by lambda into bracket. What is NL? N nothing but C by V. C by what? Vn minus C by Vr into what? T. It is. T is the thickness. Then phi equal to 4 pi by lambda into C is the common, 1 divided by Vn minus 1 divided by Vr into what? T. This is the what? The final derivation for this. I hope that is clear for you. It is also important from the point of examination. This is also important here. Here is very confusion is here. NL minus NR. Because what kind of solution I have taken here? Consider dextrorotatory. That's why in dextrorotatory, VR is greater than what? VR. One important thing you should remember in the assumptions here. Whenever there is plane polarized light will be enters to the optical active substance, it splits up into what? Two parts. One is clockwise rotation and another one is what? Anti-clockwise rotation. If the substance is inactive, the speed of clockwise rotation and the speed of anti-clockwise rotation, that both are what? Same only. When there is a speed is same here, there is no phase difference is created between the incident and emergent light. But if at all if it enters the plane polarized light, if it enters into the optically active substance, then certainly that is the phase difference is created, because the speed of right-handed rotation and the speed of left-handed rotation both are what? Different. So that a phase difference is developed between the incident wave and also what? Emergent wave and all that. Okay, it was an easy way. It is very easiest derivation and all that. Easily you can score if you prepared well. Hardly it needs nearly about 10-15 minutes is required to prepare this. Okay, my dear students, I completed your all your 100% allotted syllabus. I completed. Only there is, if you want that I can solve some problems on the Brewster's law and specific rotation and all that. That I will do it in the next video. I'll do it. That is the last one. That is okay. It is all up to you. Sincerely, I completed my allotted syllabus. I completed. How effectively you are reading and all that, it is left to you. Thank you. Goodbye.